thanks a lot for the introduction and for inviting me, and for all of you to come to my talk. It's really great to be here sharing some of my work. I'm going to be talking about metascience, so this field that has been thriving during the past decade in response to the replication crisis. So I'm going to start with, of course, if my pointer works, with that.
See the words, I click on here.
Oh, on the Windows active, yeah.
I'll try now.
Yeah, perfect. So I'm sure that like most of you here have heard about the replication crisis, right? It's already been a decade of discussions about the replication crisis. So it was around the early 2010s when the first failures to replicate in social psychology started to appear, right? So what happened was that at the time, so psychologists got interested in the replicability of important findings in social psychology specifically, and they were not replicated. So these were findings that made it to textbooks, were part of the curricula in psychology programs. And people at the time thought, well, you know, this is a problem for social psychology. And very quickly, the circle started expanding, covering other areas of psychology, cognitive psychology, for instance. So there is this report from 2015, very famous at this point, from the Open Science Collaboration, showing that about a third of findings in experimental psychology are replicate. Now, the worry was also extended to biomedical research, and there are reports from pharmaceutical companies, right, when they were trying to replicate findings in landmark journals in the academic literature, they found that only a fraction of them are replicated. Now, this information is private. There have been some efforts in academia to assess the replicability, for instance, of cancer research, and the results are not very encouraging there either. Now, there is this recent report that I contributed to with some colleagues, in which we look at all the evidence that has been collected in the past 10 years of research on replication. And there we look at multi-site replication projects of important psychology findings. And then we find that about only half of them replicate. So a lot of different parties have been affected by the replication crisis. On the one hand, scientists, of course, to the extent that we build on the works of others, if what we're building on is not reliable, not replicable, then we have a problem. It not undermines scientific credibility. For philosophers, and this is how I got interested in this topic, we see a discrepancy, a mismatch between the nice theory that we have in philosophy of science about how science makes progress, about how science changes, and the reality, right? So there is this huge gap that you know, there has been work now in philosophy. This has changed a lot, but still one area in which I think we have to look at the work that we do in philosophy and see how it relates or doesn't relate to the practice. And as members of the public, of course, so we are consumers of science. And I think in an environment in which we want to encourage people to trust science, in which we want to make the public trust science, something like the replication crisis doesn't help, right? So we want to tell the public, look, trust science, for instance, in other domains when it comes to climate change, vaccination, and at the same time, you know, you see this also making the news. A lot of findings in science don't replicate, right? So there is this a worrisome situation when it comes to science communication that starts with these problems of replicability. And of course, also as members of the public, we can wonder if a lot of the research doesn't replicate, how are we using the public funds that go to science? So how is the scientific community reacting? This is what I'm going to be focusing on. So in the past 10 years, there has been this wave of optimistic scientists, metascientists that have sort of taken the lead, trying to understand the causes of the replication crisis, proposing solutions. For instance, the concept of a questionable research practice has been very central, right? So all these small tweaks, changes that you can make through the research process that lead to less reliable science, right? So that has been identified as one of the culprits, along with bad statistics. And there are also suggestions for reforms, right? So we should move from classical statistics, start doing Bayesian statistics, something else, and then we would expect science to change, improve, publication reforms, changes in how funding is structured, and so on. And they're also designing all sorts of technological tools to support those reforms. Some are very, very keen on this idea that metascience could rescue the replication crisis. So this is a movement that has gotten a lot of attention for this reason, kind of as a solution to all these problems of replicability that we have seen in the past 10 years. Now, the term metascience is not new, right? So metascience as a term and as an area of research is already been going for a few decades. However, only during the past 10 decades, metascience can be seen or is, I think, emerging as an institution. I'm going to explain what I mean by that later. And also importantly, metascience is adopting a sort of authoritative position, right? So we have this new group of scientists telling the rest of the community what to do. And I also think that that's interesting to look at. So here are some of the questions that I'm going to raise in this talk, and I'm going to give answers to some of them. So first, how did metascience emerge? Is metascience a revolution, as some of authors contend? How does metascience relate to philosophy of science and other fields that look at science from sort of an external perspective? And is the current hype around metascience counterproductive? So I think that in some sense, it is. So why does this matter? I think kind of related to the same reasons why we worry about the replication crisis. So metascience has the potential to transform science radically. So we should pay attention to that. For philosophers, I think it's a little bit uncomfortable that a lot of what they do sort of overlaps with work that we do in philosophy of science. So it's interesting to see how it overlaps and what we can do about that. And I also think metascience is a good test for philosophical theories, right? So we have a lot of stories about how science changes, how scientific fields emerge, and we can try to apply that to metascience. So first, I'm going to give you sort of a general overview of what metascientists do, show you some examples so you have an idea of what this field is about. Then I'm going to try to look more systematically about what the novelty of metascience is or what it could be. And then I'm going to look at some contextual factors that are influencing this rise of this new field. Okay, so here's a very short, maybe responsible history of the field. Something like metascientific spirit can be traced already back to the first writings theorizing about modern science, right? So you have Comte, for instance, saying that science should be reflexive, meaning that we should not only investigate empirically the products of science, but also the methods of science, right? So we should consider the methods of science not as this external fixed entity that we apply to empirical phenomena, but we should make them empirical phenomena as well, study them, see how they work, don't work, and change them. Even though this idea is rather old, only until the 20th century you see clear expressions of this sort of reflexive interest on method. And this is perhaps what we could call the first wave of metascientific studies. And these are, I'm sure many of you have heard these labels before: scientometrics, bibliometrics, journalology, all of these fields that study quantitatively the publication landscape, right? So these are perhaps what you could perceive as the first wave of metascientific findings. What I find interesting, though, is what has happened in the 21st century, which is that metascience is becoming institutionalized. And what I mean by this is that you don't only see people producing more papers on the topic, but you also see changes in the communities that study these topics. So the number of publications is rapidly increasing. There are a number of centers and societies that promote metascience. Metrics at Stanford, the Center for Open Science, Center for Scientific Integrity, Meta Research Center at Tilburg, the Meta Research Group at Melbourne, right? So what has happened is that you have people doing this sort of first order work in their disciplines. They realize that something is not working, and then they think, well, maybe I should stop doing this first order work and start fixing things on my field. And then they realize that people have been having the same kind of intuition in different fields, and then they just come together and converge in these centers. There are more dedicated conferences, and there's a growing community. Also, something interesting and noteworthy is that there is now a new generation of scientists that have been raised in a culture in which everyone is suspicious of the discipline, right? So you have a lot of early career scholars that unlike 10 years ago, were already raised thinking that most of their findings in their fields don't replicate, that they should do something about that. So you see a lot of attention and a lot of people, early career scholars, interested in metascience. And for some of them, the hope is that with the sort of generational change, things are gonna become better, because now there's this large, sizable group of early career scholars interested in scientific reform. Okay, so but what is metascience? So you can take the literal definition. Metascience is the scientific study of science, right? And as Fiona Fiedler and other authors have said. So this is rather naive, of course. So what is science, right? And what is a scientific study, right? So we don't have like really clear-cut single answers to those questions. You can also think about it from a descriptive and a normative perspective, right? So what are metascientists doing versus what should metascientists do, right? So that this first pass dictionary definition doesn't help much. So what I'm going to do is to kind of give you an idea of what they do by showing you examples of the sort of projects that metascientists engage in. And I'm going to offer here kind of a taxonomy of different things that metascientists do with some examples. So first, and this is how the field emerged in the 70s and 80s, is what we could call descriptive projects, right? So these are projects that try to quantify different aspects of the publication landscape and hopefully make inferences about how science works or doesn't work based on that. So they employ the tools of network theory to try to understand networks of influence of theories, of authors, and so on. There's also recent work, or at least work in the context of these discussions about replication. For instance, this paper by Fanelli is a descriptive project, an example of this, in which you can look at the proportion of negative results in the literature, right? So, and then what he finds is that if you look, first, if you believe that there's a hierarchy of sciences, and then if you look at the top of the hierarchy, you see that there are more negative results reported in something like space science and geosciences, and fewer positive negative results reported in psychiatry and psychology, right? So that's kind of a descriptive project, kind of telling you, look, there is a problem here, a publication bias problem, when you look at some fields. The second kind of type in this taxonomy is what we could call inferential projects, right? And these projects are projects that are also traditionally associated with metascientific work. So basically meta-analysis and error detection, right? So you do a lot of studies and then you pull them together, then well-known meta-analytic tools to try to observe trends, aggregations of effect sizes, to see whether the bulk of the literature suggests that something is the case or not. Error detection techniques, trying to observe patterns of what you would expect in the presence or absence of publication biases. So that's also some work that traditionally is regarded as metascientific work. Some stuff that is happening more recently is kind of developing new tools to do, the first two things that I mentioned, right? So there is this worry, well, maybe worries that have been voiced in multiple, from multiple perspectives, worries that something like meta-analysis doesn't quite work. Something that the error tools that the error detection tools that we have don't work. So there's a new wave of work trying to develop, let's say, the next generation of these tools that are going to help doing these projects. To show you a couple of examples, so StatCheck, right? So this is kind of a tool that checks the consistency of statistical reporting, right? So there are like these relations that should hold between the different values that you report in your statistics if they are coherent, right? And you would expect right? That when you look at published findings, that most of them would be consistent, internally consistent in terms of these statistical values. So now you can do that systematically, right? Like going through large bodies of literature and check whether statistical reporting is consistent or not, and then the results are not very encouraging in that. A little bit of an aside, so they did that also for experimental philosophy. Experimental philosophy is doing perhaps a bit better. Another example, right? So this is the P curve developed by Simonson and colleagues, right? So that helps you notice whether there's publication bias by looking at distributions of p-values, right? So their distribution of p-values should have a certain form if the results are not p-hacked, right? So to the extent that you deviate from that, then you can think, well, there's some sort of publication bias, some form of questionable research practices, because the p-values don't correspond to what you would expect if there wasn't something wrong going in the publication record, right? So these kind of examples of efforts to develop the tools to detect error. Fourth category, so empirical studies on the scientific system itself, right? So you can have, you can make proposals. You can say, yes, science is wrong in X, Y, Z ways, and there are tons of proposals. You have suggested, for instance, that we should do more adversarial collaborations, right? So this procedure in which you have two teams that disagree about one particular matter, right? So I say hypothesis P, you said not P, then we come together, we design a study that would satisfy us, both of us, then we run the study together, and then we report what we find. The hope, this was advocated, for instance, by Daniel Kahneman in the context of psychology. He said, look, you should start doing more adversarial collaborations to resolve these disputes after replication failure. And then you can ask, well, is this actually a good intervention or not, right? And you can test that empirically, right? And there are efforts to see to what extent adversarial collaborations do solve these disagreements that you see after, like people contradicting each other, replication failure. So the results are not very encouraging on that front, right? So you can, I guess the idea here is that you can take that empirical spirit to investigate the suggestions for intervention. The role of replication on self-correction, right? So it's people worried, well, there aren't that many replications. Maybe the solution is we should replicate more. But now you can ask the question, is that actually effective for what we expect replications to do? So we would expect replications to help science self-correct, right? So that's one of the key reasons why we would do replication work. And then you can look empirically at whether replication is actually helping self-correction. So there is this interesting work by, for instance, Tom Harvike, and in which you can look at findings that have been not replicated using very convincing procedures, right? So you have pre-registered multi-site projects that very decisively show that one finding doesn't replicate, for instance. And then you can trace how much impact those findings have on the perception that people have on the original finding, right? And then the results for some of them are not very encouraging, right? From some that you would expect, if science self-corrects, you would expect perhaps the citations to decrease, perhaps the citations to be less positive than before. And then it seems that all these efforts, massive efforts, that in some cases are done to assess replicability, and perhaps not having this effect on self-correction. Another example, the case of badges, right? So these badges, if you haven't seen them, are kind of these little nice icons that you could get on your papers if you use certain practices, right? So if your work is pre-registered, then you get the icon, right, that says yes, your work is pre-registered. That's great, and then you can test empirically. Okay, to what extent does this incentivize actual good practices in people's work? Now, so those four are kind of like the sort of projects, kind of broad categories of projects that people do these days in data science. But what I find interesting is that these are parts of an argument, usually, that ends up in some sort of normative recommendation. It's like, well, they use all these four types of evidence to further one suggestion for reform. And then you can think, well, maybe you can do some sort of a feedback loop here and kind of like think about the next iteration of new proposals and how they work or don't work. Okay, so now, this is sort of kind of an example. So now we can think perhaps a little bit more systematically about where the novelty of metascience lies. What I'm going to do is kind of suggest different options and also suggest that perhaps they are not where we should focus if we want to say that this is a new field that is important, that is novel and so on. So first you can say, well, the subject matter, right? And for this audience, right? So I'm sure that you already think this is not going to work, right? So there are other fields that study science from an external perspective, right? Us, of course, history and philosophy of science, sociology of science, science and technology studies, right? So there are long traditions of fields taking this sort of external perspective. Now, you can say, well, there is division of labor. So everyone is kind of doing their own thing. They look at science from different perspectives. They are doing their own kind of projects. There isn't any problem here. However, I think there is an overlap between these different fields that is not trivial. When you look at how metascientists advertise their work, you notice that they are actually interested in general questions about science, philosophical questions. So what is the nature of scientific error? So what is the nature of progress? What is the nature of change? And then recently, things are also working kind of in the other direction. So it took some time for philosophers of science to get interested in replication issues. However, at this point, there's already a literature in philosophy that is looking at questions that you would think are primarily metascientific questions, right? So questions about, yes, replication, open science, publication practices. There's a lot of interesting work in philosophy looking at that. So, if subject matter is the same, then how is metascience different? So you can step back a little bit here and think, well, does it make sense to demarcate metascience, to say to what extent metascience is different from other fields, right? So this would be sort of a kind of second order analog of the first order demarcation problem, right? Then you can think, well, why is the first order problem interesting, important? Well, because we want to distinguish science from non-science as something that is epistemically privileged, something that is epistemically perhaps better than something that doesn't get the label science. So perhaps with metascience, with respect to these other fields that look at science, you can say, well, maybe there is some sort of epistemic privilege, right? Subject matter is the same, but maybe there's something that makes it epistemically more valuable than other fields. Another attitude could be to say, well, stressing disciplinary boundaries sometimes is not very productive. And I think in metascience, some people have this attitude. Some authors kind of view the field not so much as a field, but as a community of people that share an interest. They say, well, we have the interest of making science better. Everyone who has that interest is welcome. And you have in theory, you would have the scientists and also the philosophers, humanists, and so on. I think as a matter of practice, that doesn't seem to be happening a lot, in the sense that the community is not really that cohesive, right? So there seems to be an adversarial attitude when it comes to the non-empirical fields that have this interest in making science better. Usually when you see, for instance, interdisciplinary conferences on these topics, there are like, parallel conferences happening in the same, buildings and at the same time. And I think the issue that there's this focus on the novelty of what they do as being the empirical component, right? Is that, well, there's something that to the approach that is its empirical nature, which makes it different. So some authors view metascience as engaging with philosophical questions about science, but using empirical methods. And here we can think of this in terms of what some authors in philosophy would call like the spin-off model of discipline creation. So this perhaps a little bit self-serving idea that we like in philosophy, that we have like philosophy as the core, and then the different scientific fields have been branching out from that. So maybe you can think, yeah, maybe metascience is the successor of philosophy of science, right? What would be interesting to think here is it more like the change from let's say natural philosophy to physics, or more like alchemy to chemistry, right? Now some practitioners do have that view. Some practitioners would say that science is superseding, whatever came before, right? So this is this new field, and then it constitutes a radical departure from the work that has been done in different traditions. This can be seen, in the resistance to engage with non-empirical fields, the lack of interdisciplinary discussions, lack of citations, right? You can see a lot of people kind of working on these same topics in these different communities without much citation between each other. Now, maybe this is changing, but I'm not entirely optimistic about that. Now, one worry, and perhaps more one reason why I think this way of thinking about the field is not productive is that a lot of the work that metascience needs is conceptual in nature. So we have been in 10 years of the replication crisis, and there isn't really a consensus about what a replication is, for instance, right? So there are different notions that come from different literatures. There is this distinction between direct and conceptual replication that people use, but everyone agrees that it's not really a good distinction, or at least doesn't capture a lot of different types of experiments, right? And that's fundamentally conceptual work, right? What counts as evidence, what counts as progress, what counts as self-correction, right? So all these things are in the background of a lot of metascientific projects, right? So you might think that the work is empirical, but you're already making commitments about all of these notions when you engage in a metascientific project. And this is work that is not gonna be solved primarily by doing empirical work. So I don't think, metascience should be viewed as some sort of a spin-off from philosophy of science. And to the extent that it could be, I think it should be based on having some knowledge of what's happening in other fields and what doesn't work in those fields. To give you an example. So, you could have, this sort of response. You can say, well, metascientists can also do conceptual work as many scientists in their disciplines do, right? Many of the more sophisticated scientists are actually very philosophically curious and do think about the foundations of their fields, right? So it could be that's the way to go. And actually, I would say yes, a lot of the perhaps more interesting projects in metascience are those that actually have a philosophical component. But there is kind of a risk of reinventing the wheel and repeating mistakes. So here's one example of what I mean by that. So here's one problem. So the problem of methodological individualism, right? So the idea here is that if you want to think about scientific errors, scientific progress, then you're going to look at statistics, methodology as the primary factors, right? And that has been perhaps one way of thinking about metascience. However, from the philosophy of science, we know that there isn't a formal logic to the scientific process, that social structures largely impact scientific progress. And this is sort of an idea that is familiar in philosophy of science after social epistemologists, feminist epistemologists, since at least the 80s, right? And something that I think happens is that it's sort of a kind of a rediscovery of this idea in the metascientific community. It's like, well, now we have to look at the social structure of science and how that affects scientific progress, right? And this has been a lot of attention during the past decade. But I think it's an idea that has been familiar already for scholars in philosophy for a while. Another response, and I think there is perhaps a little bit more to this response. So the work of philosophers of science is vast, difficult to understand. Metascience can't easily engage with it. There's a problem with audience, of course. So I think many of the work that we do doing philosophy of science is intended to be used, consumed by other philosophers of science, right? And then we're trained, we use all our, jargon and so on. So it's hard to expect people from the outside to come to the literature and find the useful nuggets that they can employ in their projects. So yeah, a lot of philosophical work that is relevant to practice often doesn't reach the science. And I think what needs to happen here is to have more cross-disciplinary work. So there are some scientists that are really curious about philosophy, right? And they read philosophy. There are also philosophers of science that are kind of interested in that, and they go there. So that I think is perhaps what needs to happen to address this issue more than the community sort of evolving independently. Okay, another possibility is to think, well, there isn't, I'd be suggesting that the novelty of the field is not subject matter, is not method. So maybe there's something about the theory. And there's some suggestion, at least this is not super systematic from their perspective, but there's some suggestion that there's something revolutionary happening in science, right? So you have, for instance, Emile Desir saying, well, there's a credibility revolution that is happening. Ryan Nozick, the registration revolution. Now, of course, what we mean by revolution. We have perhaps a very technical understandings of the terms in philosophy. Now, some authors do contend that some of the sort of technical use of philosophy applies in this case. That there's a transition from a period of normal science into a crisis, being the replication crisis, and then a transformation into some sort of new paradigm. So we can ask the question, so is this a Kuhnian revolution, for instance, to the extent that we believe that's a good way of understanding scientific progress and change? You can perhaps wonder, well, maybe the replication crisis is something like a Kuhnian anomaly, right? So this period in which a lot of the things in the current paradigm are not working, and then there needs to be some sort of radical change. Now, according to that model, there needs to be some sort of fundamental theoretical change, right? So the exemplars, of course, are the changes in physics in the 20th century, right? So those are due to clearly identifiable theoretical changes, right? And there isn't anything like that happening in this context yet. So if there's a revolution, it's not in that Kuhnian sense. Now, I think this is another understanding of revolution also from the philosophical literature, which is the idea of a tool-driven revolution. Also, for instance, more recently, John Bickel, about neuroscience, makes this claim. So the idea is, well, if you look at the history of neuroscience, the revolutionary changes don't follow the dynamics of the Kuhnian model. It's more developments that happen after technical developments, right? So the rise of neurophysiology or neuroimaging, right? So these developments, technical developments happen, and then after that you have the theoretical developments. So maybe I think something like that could be said about metascience, right? Now we have a lot of computational power to do large-scale data mining projects, right? They were not feasible some decades ago. Conceptually, the insights were perhaps already there, but now we can do this relatively easy. Large-scale collaborations, right? So that's also very feasible now. So multi-site projects, which are central in the science, those are feasible now in a way they were not before. That's perhaps what is driving, or could drive a revolution if there is one. Okay, so now I'm going to talk about perhaps another way of understanding the emergence of this field that has to do more with the contextual factors, sociological factors around it. Some authors in the sociology of science have looked at these sort of fashion dynamics in science, right? So this is not extensive work. I'm just borrowing here some some ideas that I think to some extent could apply to what we have seen in the past 10 years. So what is a scientific fashion? It's a situation in which the hype about the scientific field, program, project does not track epistemic import or epistemic merit. Now, of course, if I say fashion and I'm talking about science, you would say, how dare you? If anything, science is not fashion, right? But something that these authors kind of stress is that this sort of phenomena can arise without postulating deviant motives in the scientific community. That's, I think, important to acknowledge, that everyone could be perhaps trying to do good work and still follow this sort of fashion dynamics. You can make a distinction. There's perhaps a bit of a stipulation, but I think it's a useful distinction between what's fashionable and what's fashion. And you can refer to fashion as cases in which there is excitement about some theory, project, field with no epistemic support, and something that is not fashion, but perhaps fashionable, is when there is this excitement plus some solid epistemic support, right? An example of this is biology after Watson and Crick's DNA model, right? So there is a case in which there was a clear epistemic support, and then the community of biologists, a lot of them started working on molecular genetics, right? And then you would say, well, this is actually not fashion in this sort of epistemically not useful way. These are pictures that you can identify in fashions in general, in scientific fashion, and in fashion in the particular case of metascience, I think. So first you have elites, right? So small groups of scholars that set fashions. Then you have phenomena of conformity, right? Scholars that adopt practices that they don't fully endorse. Why? Well, it's sort of kind of a contagion phenomenon. You see, well, everyone is kind of doing it. It's becoming the norm. Therefore, I'm gonna do it perhaps without really understanding what it is about. This leads to performativeness. Society is pursuing a practice, a theory, to elicit approval from others. And this process, I think, or this is a process in which you have a period of excitement. So this drives the popularity of theories and methods, and then disappointment, right? And then in this literature, these authors identify, for instance, the case of N-rays as that, right? So this created a lot of attention, many people got interested, and very quickly they were disappointed. They realized, well, this doesn't deliver the epistemic benefits that it was supposed to deliver. Therefore, we move to the next thing. So how does this relate to metascientific work? So elites. So elites, I think it really depends on whom you ask. And I think it's fair to say that in the first couple of years of this field, metascientists were a minority, right? So there were a small group of people kind of interested in making changes and sort of fighting against sort of establishment. Now things have changed, right? So there are a lot of very prominent scientists, right, doing metascientific work, right? So I think you could think that in a sense there's already a metascientific elite that has a lot of influence in how the rest of the scientific community behaves. So think about the open science movement, for instance. So that a lot of people have heard about the open science movement and about the sort of practices that they should do, and they feel this sort of pressure to pay attention to what's happening there. And what's the problem? I think that some scientists are adopting open science as a fashion, and this leads to performative open science. And here the story is the following. So open science conflicts with the traditional structures of science. It conflicts with the way in which science is organized, the way publishers, many of them for profit, are organized. Journals, editors working under those structures are also affected and kind of in tension with those traditional structures. So what's the solution? So the publication system has tried to incorporate some of these practices within the traditional structures. Why? Well, some authors do want change. Some authors say, yes, we want to do, for instance, have open data, to have open protocols. And then the publication system says, okay, we want to make the scientific community happy, but without really affecting too much our business model. So they try to fit the practices, to the extent that the system allows. And the scientific work, to the extent that is happening within this context, is also subject to the same problem. So I'm just going to mention quickly, this is a whole other project, but pre-registration is facing this problem. So the practice of pre-registration, if you're not familiar with it, is the practice of stating all the hypotheses to be tested models, analysis protocols before data collection, and making that information publicly available. There are good epistemic reasons to do that. Now, how does that fit in the current structures? Well, it fits in a sort of opt-in way. You can decide whether to do it or not. Even in cases in which it is clear that there are good reasons to do it, it's still an opt-in system. And when you look systematically at what happens with research, is that it doesn't accomplish the epistemic benefits that are expected. So there are a lot of there are two problems, at least: an under-specification problem. So pre-registered research is not specified enough to sort of constrain unwarranted flexibility. There are undisclosed deviations, right? So you do a pre-registration because you want to commit to a plan, and of course you can deviate from the plan, but maybe you should disclose the cases in which you're committing to the plan, so that consumers of the literature could look into that. And there are many cases of undisclosed deviations. And maybe you can wonder whether this affects replication too. Is there performative replication? People kind of jumping on the boat because it's sort of fashionable, but perhaps losing track of the epistemic benefits of the practice. Now, if we kind of believe the sociology that think about this process fashion, then there is kind of a risk of there being a decline, right? So people would lose interest because all of this, in many cases, time-consuming, demanding things are not really giving the epistemic benefits, right? So yes, sharing data is costly. Sharing, making everything public, well documented, open is costly. And then if you realize that it is not giving the epistemic benefits, then people might lose interest and move on. Okay. So some concluding remarks. So some authors view the emergence of metascience as a sort of revolution, right? And I think a lot of important things are happening, and I think the field has a lot of promise when it comes to making changes and making science better. But I think we should be cautious about the hype. So there is one worry that the sort of dominant narrative, I think that it has gotten traction, is this idea of metascience being good because it's empirical, right? And I think that could lead to methodological fetishism without conceptual clarity. That doesn't mean that we philosophers should be there, but I think that we should acknowledge that conceptual work, whoever is doing it, should be part of what happens in metascience. Metascience I don't think is productive to view it as a sort of a spin-off from philosophy of science, something that supersedes philosophy of science. And I don't think metascience should be seen as authoritative in understanding replication crisis and offering solutions. I think it's better to view it sort of as another of these fields that is contributing to the understanding of science from an external perspective. Now, what I think novelty lies is actually the normative component, right? So the fact that the metascientists don't end their work when they publish a paper, right? So usually more of the interesting things happen after the paper is published, and then they reach out and try to influence the different stakeholders to make changes in the system of science, influencing funding agencies, universities to change the way in which they do things, the ways in which they reward things. So that activism, I think, is what perhaps is novel about the field and makes it different from things that happen in other fields. Yeah, but I think there's a risk of decline if it's perceived in this sort of fashion thing that people are kind of doing as a result of being immersed in a culture in which everyone else is doing the same. And yeah, so that's what I have. Thank you.